Hi everybody, welcome to Mrs. John's lesson. This is for Year 11 Physics and this is lesson 2 on motion. So in this lesson, I'm going to cover the difference between the terms distance and displacement and also touch upon displacement time or distance time graphs. So first of all, what's the difference between the words distance and displacement? They both have the symbol D to represent either distance or displacement, and they're both measured in the same units, which is meters. Now, here's an example. So let's say that's your house here and that's your school. Okay, so that's where you are. So each morning you're coming from home to school. And let's say you're walking. And so you walk along this path, you pick up friends along the way, maybe stop at a bakery, buy yourself some hot chocolate, and then you finally reach school. So the length of this path is the distance traveled. However, displacement is the shortest distance from start to finish. And you know that the shortest distance between 2 points is a straight line. So you started at home, you finished at school. So your displacement is the straight line between home and school in that direction. Okay, because displacement is a vector and distance is a scalar. Okay, some more examples about distance and displacement. So you can see 3 dots here. So let's say I'm starting at the dot and I am walking 3 meters forward. So I've walked 3 meters forwards. My distance is 3 meters. My displacement is also 3 meters over here. Okay, so now let's see. This is example 2. So I walked 3 meters forwards and then I turn around and I walk 2 meters backwards. So this is 3 meters forwards, 2 meters backwards. What is my displacement? My displacement is the shortest distance from start to finish. So my displacement is 1. So 3 minus 2 is 1. And it's 1 meter to the right. So my displacement is 1 meter to the right, whereas my distance, my total distance traveled is 3 plus 2, 5 meters. So they're 2 different answers. Okay, then let's say I walk 3 meters forwards and 3 meters backwards to come back to where I started from. So my displacement here, write out the whole word, is start to finish. You're exactly where you started. My displacement is 0. However, my distance, the total distance I've traveled or walked is 6 meters. Okay, then last one. Let's say I start here, I walk forwards 3 meters, and then I turn around and go back, but I go past my house and I walked back 4 meters. Okay, so over here, my displacement is the shortest distance from start to finish, and my displacement is 1 meter to the left. So it could be negative displacement. These are all positives. Okay, and whereas my total distance traveled is 3 plus 4, 7 meters. So that's the difference between distance and displacement. Now let's come on to distance time or displacement time graphs. So I'll just rub the board. My board is a little old, so I'll just put some spray just to make it a bit cleaner. Okay, we're all good now. All right, okay. Let's look at displacement time or distance time graphs. Okay. So in year 10, you learned something about distance time graphs. We didn't do displacement time, so I'll start with what you know. Okay. Okay. Put these things too. See this better now. Okay, those those are displacement time graphs. Whenever we put your graphs, you also need to write the unit in which these quantities are measured. So distance in meters, time in seconds. So you know, if you have a graph that is a straight line like this, it means it's stopped, it's not going anywhere. But if it is a line going that way, it represents constant speed forwards. And if you're speeding up at a constant rate, then you have acceleration. And then you also have one more if you are slowing down. So that if you're slowing down, you've got deceleration. Okay, so those are the graphs that you're familiar with. Now, if you have two lots of constant speeds, so let's say on this axis, this is a distance time graph. So distance in meters, time in seconds. You've got graph line 1 and you've got graph line 2. So if you notice, graph line 1 is not as steep as graph line 2. So the steeper the slope, the faster the speed. Now, how do you calculate speed from a distance time graph? The gradient of the graph, which is rise over run, gives you the speed. Okay? Right. Now let's come on to some more descriptions where it's a displacement time graph. So things can be positive or negative. So I could go below the x-axis. Okay, so if I draw something like this, displacement, time measured in seconds, displacement in meters. Let's say you start off like this. Okay, this 0 is home. It's still wet from the spray. Okay. Let's put some numbers. And let's say that is 25. Okay, and let's call this A, B, C, D, E, and F. Okay, so the first one, A represents stopped or stationary or at rest. You're not quite at home, you're 10 meters away from home, but you're not moving. B represents constant speed or constant velocity forwards. Okay, so when I'm saying direction, that's to do with displacement. C, you're 25 meters away from home, but you're not going anywhere. You're at rest or you're stationary. Now, D represents constant speed, but it's coming down, so it's going back. Okay? And E is still constant speed going back, but you've gone beyond your home. It's like going, you know, the example I showed you before, and then you've turned around and then you're coming back home. So this is, if this is your home and anything this side is forwards, okay, so you're going from home. So initially you're sitting here, you're 10 meters away from home, you're moving constant speed for some time, and then you stop for a while, and then you turn backwards and you come and you're coming back home. And then this part here, this is back home, this point here, this part here is you've gone beyond that, and then you come back here. So that's this journey. So this is your F, this is your E, this is your A, that's your B, C is stopped, and then that's your D, and so on. So I've just linked this line to that graph. So I hope that helps. Bye for now.